We are looking at function, the characteristics, the definition, and then we're going to do some examples and non-examples. So you should have both of these papers. So using the notes from yesterday, if you have not done the notes from yesterday, you need to make sure that you do that before tomorrow. We can write the definition. A function is a relation where each input, so remember input is our x, I'm going to put in parentheses x, produces exactly one output. Remember, output is our y values. Okay, now characteristics. So how do we determine if a relation is a function? What are we looking for? Yep. So x's will not repeat, right? X values do not repeat. That is the main one. If we're given ordered pairs, we would only look at the x values. If we're given domain, we're looking at the x values for domain. What is the other way we can test it out?
Vertical line test.
Vertical line test. So I'm going to put on here passes the vertical line test. So these are the two characteristics. So sometimes you'll see it written as VLT, vertical line test. Okay, now what you are going to do is you're going to cut out each one of these relations and you're going to put it under either example or non-example of a function. So let's look at this. You can use tape or glue. So I'm going to look at this one first. Something you have to pay attention to once you cut this out is that, remember, your x-axis goes left and right and your y-axis goes up and down. So this does not pass the vertical line test. So this goes in the non-example. Ooh, this one's hard to tell. Oh, so on this one, you just have to make sure that you can see your numbers, everything's upright. So on this one, it's just a line that goes from one area to the next. It passes the vertical line test, so that is an example. This table, 1 matches with 2, 2 with 4, and 3 with 6. X's don't repeat, so this is an example. Input-output table. So we're looking for X's repeating. Do the X's repeat? Yeah, 4 is with -2, 4 is with 2. 1 is with -1, 1 is with 1. Yep. So those are the spots. So this is a non-example. Ordered pairs. You only look at your X's. So do the X's repeat on this one? No. 1, 2, 3, 4, and 5. X's do not repeat. So this is an example. And the last one. Do X's repeat? Yeah, 1 goes to 3 and 4. Can't do that. So this is a non-example. So you can either glue or tape these in. Don't cover up where it says examples and non-examples. So you should have everything glued or taped in. If you covered up example and non-example, make sure to write that out to the side. We're going to glue this in the next page in our journal, which it is page 31 right here. Let's go ahead and glue that in. And we are moving on to our next topic, which is independent and dependent variables. So fold this in half. So that this is the front of the foldable. Write your name on it. Okay, so we talked a little bit about independent and dependent when we had the foldable for identifying functions. So inputs are independent, outputs are dependent. Something you have to remember is input is our x. So put x on top of input. Output is y. Well, I guess I could put it over to the side like that. X and y. So all of these different things, input, output, domain, range, independent, dependent, they're all matched with either the x values or the y values. So independent is x. Dependent is y. So outputs are dependent values as they depend upon the input. So we are going to write in here change in the independent variable causes so if you change your independent, that's going to cause your dependent to change. So it causes change in the dependent. X is always the independent variable. And Y is always the dependent. Examples of independent could be time, number of people, and also, so we'll do that, time and number of people. Those are two examples. Two examples of dependent would be salary, total cost, so this is independent and this would be dependent examples. Okay, so let's look at some examples now. Open up your foldable. When identifying independent and dependent, it will be a word or a letter, not a number. Okay? So don't say 5 is my independent variable, because remember, a variable could be any number. So that's why it's not a number. It's going to be a word or a letter. So independent is always X. So I'm going to put that over here. Independent is always Y. So we've got to identify in these examples which one's independent and which one's dependent. So if we look here, we have number of days, 1, 2, 3. Cost, 150, 200, 250. So out of these, which would be independent? Number of days or cost? Number of days is independent. Cost depends on how many days. Exactly. So this would be number of days. The dependent would be cost. If you were to use this horizontal table, X is number of days, Y is cost. X goes on top. X increases by 1 each time. What does Y increase by? 50. Do y'all remember what that's called? Rate of change. There we go. 50 is our rate of change. Let's look at the next one. H of M equals 1500 minus 15M. So I need to replace this with Y, replace Y and X. If it says this equals, what variable can I replace H of M with? If it's a linear function, Y. Y equals 1500 minus 15x. So now that I replaced it, you can look, H of M is my Y. So where does H of M go? Dependent. We don't know what this means at all. We don't have any context. We just have an equation. So H of M, H depends on what M is. See how they're together, H of M? That means we're going to plug in a number for M, and that's going to change my value for H of M. And then we have M is our X. Oh, I put X there. I should have put M. And put equals M. Let's look at the next one. Abdul brings reusable shopping bags from home whenever he goes to the store. The number of bags he brings is based on how many products are on his shopping list. Did y'all see that? The number of bags he brings is based on, what's another word for based on? Depends. Depends on how many products are on a shopping list. So do you decide on your shopping list first or the number of bags first? Yeah, you make your shopping list first. So what does that mean shopping list is? Independent, right. P, which is number of items. I don't know, number of items on the list. I don't know why I put that. Items on the list. You make your shopping list first, and then you say, okay, I have 20 items on my shopping list. I can fit about 4 items per bag. So I know I need to do 5 bags. So this would be B, number of bags. So you make your shopping list first, and then you determine how many bags. Do one more page on this foldable. Independent variable, dependent variable. So it just gives us a situation. It doesn't tell us which variables we're looking at. Let's look at the first one. The size of a plant will increase as the amount of water and sunlight increases. Amount of sunlight. So our two variables is size of the plant and then amount of water and sunlight. Not increases, just amount of water and sunlight. So we need to determine which one's independent, which one's dependent. Which one depends on the other? Plant size depends on what? Amount of water. So if you forget to water it for a week, what's going to happen to the size of that plant?
It's going to shrink up.
It's going to shrink up. It might even die. So what's our independent? Mm-hmm. So amount of water and sunlight. You can give it tons of water, you can give it tons of sunlight, or you can give it the minimum amount, or you can give it none. And that changes how the plant changes. So dependent is size of plant. Let's look at the next one. The time it takes for a road trip depends on the distance and speed. So we need to determine what our two variables are. Time it takes for a road trip, and then distance and speed. Depends on. This depends on that. Do what? Time depends on distance and speed. So it's the distance and speed is our independent. You can decide how far you want to go. You can decide how fast you want to go, but of course you don't want to go over the speed limit. But distance and speed is independent. The time it takes for the road trip depends on our distance and speed. The last one, the amount of gas in a car decreases as the distance the car travels increases. So what are our two variables? Amount of gas and distance car travels. Those are the two variables. What depends on the other? Decreases. So which one's independent? But it says the amount of gas in the car decreases as the distance the car travels. So you have gas, and then the further you go, what's happening to the gas? It's going down. So the independent variable is your distance car travels. You can travel to and from work a couple of times, and you'll see the amount of gas go down. Or you can decide to leave it in the driveway. You don't travel at all. Amount of gas stays the same. So our dependent is amount of gas. Go ahead and glue this in the next page of your journal. Okay, I just passed out your assignment. So let's look at what the assignment is. Circle the dependent variable. Independent and dependent. All I want you to do is put an I for independent, a D for dependent. You don't have to worry about circling, underlining, or anything like that. It gives you the two variables. So read the situation and then put an I by independent and a D by dependent on here. So y'all can work together as a table group.